So thank you everyone for your time this morning. So I work with Catherine just 2 benches away in our serology department at the QAP, and she's done a great job of giving you the history of the QAP. So I'm not quite in the molecular field, but a lot of our serology programs are related to what's done in microbiology and the molecular infectious diseases programs. So we currently offer 42 programs, and they're sort of categorized in those general disciplines, so antenatal, bacterial, hepatitis.
Teresa, has the sound gone off?
Sorry, can you all see the slides now?
Yep, that's fine. Thank you.
Okay. So antenatal, bacterial, hepatitis, infectious mononucleosis, lymphadenopathy, parasite and spirochete, which links to a lot of the microbiology programs, point of care, retroviral, vaccine preventable, viral, and we also have an educational component which is not assessed, which are specimen-free case studies. So these are just case studies that we get from labs that might be interesting to trainees and clinicians, as well as laboratory technicians in the lab. We have a new program that we've introduced this year. Our first survey actually closed recently for the coronavirus SARS-CoV-2. This is mostly for antibodies and point of care, but this is also linked to the molecular infectious disease SARS-CoV-2 antibody program, which was released earlier this year, I think about April, May. Our programs are distributed in 1 to 6 surveys per year, dependent on the program and the frequency of testing in the labs. And a review of the potential programs, like Catherine said, are conducted based on participant feedback and any new tests that labs have introduced throughout the year. So to reinforce what Catherine and Rob said, most labs are required by NATA to be enrolled in an EQA program if they're providing that testing in their lab. But there are also additional flow-on effects to participating in an EQA. It gives laboratory scientists confidence in their skills and assurance that they're reporting the correct values when they do their testing. It also shows that they're actually getting the correct result when they do their testing. But ultimately, and of course the most important part being that the patient is actually receiving the right diagnosis, treatment, and outcome. So what does EQA actually tell you? EQA provides a measure of the robustness of the testing, and it shows labs the accuracy of their testing compared to their peers who might be using the same method, particularly in serology. It can potentially assist labs in identifying issues such as calibration drift with their instruments, operator variability, and stability issues that might not be detected by quality control measures alone. And it also provides information on the different methods available to measure the same measurand, so whatever antibody or antigen that you're testing for serology in your lab. And it also provides labs the opportunity for corrective action and improving their testing methods, to reinforce what Catherine has said. So this is just an example of the typical EQA cycle. So the participating lab receives the sample, and we ask them to do the testing in a specified time frame. For serology, it's usually 2 to 4 weeks, depending on the program. Once they do their testing, they return the results to the QAP on the closing date, and we analyze the results and do statistical analysis on the results returned. It's all collated into our report and then sent back to the lab for review. So once the lab has reviewed their samples once the lab has reviewed their reports, if they receive discordant results for that survey, they're expected to use their own internal quality system to do corrective action. And we're always there to assist if there are any issues that they want to talk to us about. So for serology, we provide proficiency programs to enable them to measure levels of antibodies and antigens specifically. And we provide four different types of sample types. So we have serum, plasma, urine, and whole blood, specifically for serology. We do offer lyophilized samples for a quantiferon TB program. That's the only lyophilized sample that we provide, which is different from microbiology. So the samples are sent with an indication of the expected result, and then the participation is then assessed based on consensus of the interpretive component of the program. So serology is a bit of a grey area for most labs because there's a lack of gold standard tests, which is why we use an 80% consensus rule for our assessment. There are very few tests in serology where we can have a gold standard assay, and those are usually tests that are sent to reference labs for testing. So, for example, a Western blot test for HIV would be what you would call a definitive indication of whether you've got a positive result or a negative result. The quantitative component is reported, but it's only used as part of a review to look at the variation between the method groups. So although this component doesn't get assessed, we do provide median values, standard deviation, and CV values to provide labs with information on how that quantitative method is performing. Ultimately, it's up to all users to form their own opinion based on the conclusions of the report. So this is looking at any clinical information that we might provide and commentary that's included in the report to see how they've actually performed in the survey. Again, if you have 80% consensus, it's quite easy to assess, but where there's no assessment, it's up to the lab to sort of evaluate their own performance. Like I said, a variety of samples are provided. Sometimes we have diluted or undiluted pooled serum samples or plasma samples. And sometimes this might have an impact on how the kits performed if they're not validated for that sample type. With serum specimens, we often have artifactual problems with some of the samples due to the matrix, particularly with some of our plasma samples where we might defibrillate them to improve the performance of the sample. Rethrombinization might cause reactions with some of the reagents depending on the excuse me, kit in use. Thank you. So this is just an overview of our assessment criteria. Once we receive the results and start analysis, we look at the percentage consensus. So if we're just looking at that middle tier, if there's 80 to 99% consensus or 100% consensus, the results are assessed. And then if your results match the consensus result, you're marked as concordant. If they do not match the consensus result, you're marked as discordant. If you have less than 6 results in your method group or less than 80% consensus is achieved, the sample is not assessed. And so when you have a discordant or not assessed result, we actually ask you to refer to the commentary and the overall performance table to assess your performance. When you get 100% consensus, it's quite easy. Everyone's marked as concordant. Again, this is all based on the qualitative data only for serology, although we do provide the statistical information for the quantitative component. So this is an example of a summary of performance. You can see that there are 2 samples sent out for every survey. This is an example from our dengue virus program. Ideally, labs want to be in this sort of green box. They've returned their results. The consensus results are over 80% for all of the measurands, and you're concordant for that sample for each of the measurands tested. If you do have a discordant result, something's gone wrong in your testing process, and ideally you will be looking at those measurands that have returned discordant results. So in this case, the dengue IgG ICT and the capture method has not met the consensus result performance. So we also display this as graphs. So this is a histogram representation. This is an example from our hepatitis A program. So this includes your qualitative result, which is sort of highlighted with the blue dot at the bottom of that table. So this lab has returned a positive result for their total antibody. It also highlights the kit that they're using. And the dark blue is for all the results returned. The section covered in blue is the number of labs using that particular method, so the same method that you were using. It also lists the consensus result for that particular measurand. So you've got your report and you've realized that you have a discordant result or you have not been assessed for that measurand that you're testing in the lab. What do you do next? So ideally, you'll start going through your own internal quality review process in your lab, and this requires you to perform corrective action steps and also perform a root cause analysis for why you've received a discordant result. Participants, again, should form their own conclusion based on that method's performance and the data that's been provided in the commentary. So troubleshooting your non-assessor discordant results should include a review of all aspects of the laboratory testing process. So this is your pre-analytical phase, your analytical phase, and your post-analytical phase. And laboratories are encouraged to consider the following. So the most common issues that we find from EQA surveys is that there's been a transcription error. So this is either during the labeling before the testing or when entering in the results after you've gotten the results, when you're entering the results in the portal. Is your discordant result related to method group issue? Or is it discordant compared to others using your same method? Are the discordant results related to your analytical principle? So for serology, some labs use ELISA methods or chemiluminescent methods or immunochromatographic methods to do their testing. And depending on the method and analytical principle, you might get different results. Is it a lot number related issue? Is the specimen type validated for that method? And do your results seem to be related to sensitivity, specificity? So is it too sensitive or not sensitive enough for that sample? And is a duplicate sample that has discordant results? For some of our surveys, that are more repetitive. So some of our 6 survey programs will intentionally put duplicate results that are sent at different times of the year to see if you're getting the same result throughout the year. So I was just going to go through some of the examples that we see and how you can identify this in your report. So when you have a transcription or labeling error, you'll see for this entamoeba IgG result, you've got discordant results for sample 3 and sample 4. For sample 3, the results have been reported as positive by the lab. The consensus result is negative, and we have over 80% of labs calling it negative. So it's more likely that the sample has actually been reversed because they've reported negative for the second sample. You'll notice that there's also a comment at the bottom of the report that says your result has been excluded from analysis, and this is just for the quantitative component. If you include the reverse samples, it brings down the CVs and the medians, it brings down the SDs and the medians, so that's actually excluded from the statistical analysis, so that doesn't affect the other lab's performance. So this is what it looks like on the scatter. So for sample 3, where they've returned a positive result instead of a negative result, you can see they're outside that red line indicates 4 SDs. So they're sitting outside that 3 SD range. And the opposite result, which they reported as positive, which is a negative result, it's sitting right at the bottom of the scatter graph. So in blue at the bottom, it actually shows what your kit is performing as. So you'll see your quantitative result is 2.2, but for sample 3, but the medians and CVs are at 0.54 for that sample. So in this case, it's quite easy to see something's happened in the pre-analytical phase, or there's been a transcription error when someone's entered in the results. So that's how you sort of troubleshoot that sample. Ideally, you'd ask the RCPAQAP for another sample to retest it and make sure that that's what's happened. Method group or kit-related issues. So this is if you're using a manufactured assay. On the far column, you can see the kit name. So we've got kit A to G. And you'll notice that for sample 2007, which is just that second column, you're getting 100% consensus for all of the methods. So all of the methods are reporting the same result. But if you look at kit G, they've called all of all users using this test have called it positive, but all other kits are calling it negative. So that means that there's something wrong with that particular assay. They shouldn't be reporting a positive result, especially when you've got 80% consensus. So for labs, what they should do is actually contact the manufacturer for further investigation, because that has ramifications on how you're reporting the samples for the patient. You don't want to be reporting a positive when it's negative. Sometimes we see statistical bias. So this is an example from our mycoplasma survey. For mycoplasma IgM, there's been no assessment for this measurand. The lab has reported negative. The consensus result, even though it's not 80% consensus, 50% of labs are calling it positive. So this is what it looks like when you actually look at the returned results. So in blue is what your lab would have potentially reported. But when you actually look at that first kit, kit 1, they have over 50 participants using that one kit. So out of 82, 50 are using one kit, which sort of sways the consensus reporting. So 61% of all results are coming from just that one kit. So the lack of consensus is most likely due to that statistical bias. And even looking at that kit 1, you can see there's actually no consensus within that one method group about what the results should be. And we often see this for serology, especially when the result is around the cutoff. So the clinical cutoff might be 1.1, and labs will be reporting results between 0.9 and just over 1.1, so they can't actually agree on what the result is. And for serology, when you get equivocal results or results that are low positive like this, we usually, in the labs, you'd usually send for another sample to be repeated in 14 days to see if you get that convalescent seroconversion. We don't quite capture that in our QAP reports, but we do find that a lot of labs, particularly due to assay sensitivity and specificity, have issues reporting those values. So just give me a second.
Yes, please.
So for everyone online, we're just trying to get the screen back up. Perfect. So the next scenario that we see are discordant results compared to the peers in the same method group. So in this example, you can see for sample 2006, we have a consensus positive result. And in this method group, users using the same kit, 11 have called it positive, but one lab's called it negative. So if that's your lab, something's wrong with the way that you've tested that sample, particularly if everyone else in your method group is calling it positive. So this is usually related to technical issues. That might be the instrument itself. It hasn't been calibrated properly, or the QC's actually failed, or you're using an expired kit for your testing. We do often see that sometimes in serology where labs are using expired kits. It might also be an operator issue or contamination of the sample in some scenarios. Slide's not moving.
I use the arrows at the bottom of the screens.
Ah.
That's what I used to say that.
Okay,
Yeah.
good. I'll use that. So analytical principle issues. So this is when you're using, when your measurand is using a different analytical principle for testing. In this example with the dengue virus, you can see the two highlighted at the bottom. One kit is testing for NS1 antigen using an ICT method, which is an immunochromatographic method, and the other labs are using ELISA methods to test for the NS1 antigen. So this sample was a plasma converted to serum sample, and we spiked it with culture antigen, so we know that they're supposed to be picking up that antigen. So for this ICT method, you can see there's only 52%, 53% consensus in that group, and there are 85 participants actually using that kit compared to the ELISA group at the bottom where you have 15 participants and they're actually getting a positive consensus, which sort of aligns with what you'd expect to see. The IgG is positive and the IgM is positive, so we expect the NS1 antigen to be positive. So something's going on with this ICT kit. So the distribution of results when we reviewed it did not appear to be kit or lot number related, and the specimen was a low-level NS1 antigen positive that we spiked, so you would at least expect to see it on the ICT method, but it appears that it's below the level of detection for those kits. What we suspected was the presence of the IgG and the IgM could have led to a formation of antigen-antibody complexes, particularly for ICT methods, which reduces the reactivity of the NS1 antigen. But potentially labs could be missing that there's actually NS1 antigen if they're just exclusively using the ICT kit. Lot number related issues are quite common. So in this example, everyone's testing for parvovirus IgG using the same kit. If you just look at that last result column, you'll see everyone using lot number 127024 is reporting a positive result, and everyone using lot number 120723 is reporting a negative result. So something's happened in the manufacturing of this assay. And labs are usually encouraged to contact the manufacturer. It might be a batch issue. At the QAP, when we notice issues like this, we actually contact the manufacturers as well to notify them we're about to release a report and it looks like something's gone wrong with their assay. This has ramifications for the labs, especially if they've released patient results on that lot number. And depending on the high turnover, depending if there's a high turnover for that program, you might have to retest all those patient samples. So this is just taken from our website. We have quite a lot of scientific posters that are available on the QAP website from all the disciplines on some of the testing that we do or posters that we presented at conferences. This one is based on specimen types and whether they're validated for that assay or not. We did an investigation on our EBV VCA IgM measurand for serology. So this sample was distributed in 2014 in 2 surveys and then again in 2019. In 2014, we had no consensus, and you can see there's quite a lot of labs reporting positive results. So that's the red and blue bar, and equivocal results, and we expected the sample to actually be negative. So when we did a review of all the kits, 4 out of the 9 kits that were being used for our surveys were not actually validated for plasma samples, and that's what we provided for the survey. Sometimes it's quite difficult for us to actually source serum samples, particularly for big programs, because our samples are actually commutable, so we rely on patient donation, so we don't make synthetic samples. They're actual patient samples that we use for our surveys. So because these 4 kits weren't validated, we thought we'd try and convert it to from a plasma to a serum sample for our 2019 survey. And the results show that after defibrillation of the sample, there was actually a shift in reporting of results from positive to and equivocal to negative by the participants that were using those kits that weren't validated. And you can sort of see the increase in the negative reporting in 2019. So this might be something that you need to look at when you're reviewing your reports, what the actual sample type was and if the kit you're using in your lab is validated for that test. We still do encourage labs to test the sample, even if it's not validated for plasma, because more often than not, they do get the right results. It's just that the manufacturer hasn't done enough testing to validate it for that particular sample type. Duplicate samples. So this is a cumulative performance. Catherine said that we actually provide cumulative reports for all of our reports. For the sample 2003 is a serum sample diluted 1 in 5 in another sample, and it's actually the same sample as 2002, which was distributed earlier in that year. So for that sample, 2002, the lab returned a concordant result, but when they tested it later in the year, they've actually reported a discordant result. And it's the same thing for sample 2004, which is the same as sample 2001. They've reported discordant when they previously had concordant results. So either something's happened with the kit, or it's an operator issue if a different operator's done it, or it's a transcription error. So you sort of have to go back and look at everything that we've discussed earlier in the presentation to sort of see what's caused that discordant result. Ideally, you don't want to see that in your lab. You want to always be consistently reporting the same result when you're doing your testing. So we always encourage, as part of your review, if there is a duplicate sample or replicate sample, to refer to the cumulative section. Homogeneity and stability. So we do extensive homogeneity and stability testing for all of our samples, and we have all those records on site. But this is an interesting sample that we've just had recently with our HIV point of care program. It's a whole blood survey, and the samples were dispatched on the open survey date. So this is actually a fresh sample. For the majority of our serology programs, the samples are dispatched once a year. That's usually in January, and they can be stored frozen and tested when the survey opens. But for our point of care, because we're using whole blood, the sample's only stable for about 2 weeks for testing, and it needs to be stored refrigerated or not frozen. So when we dispatch the sample, we did testing on sample 2006. This was intentionally sent out as a antigen positive and antibody positive sample. And when we did preliminary testing before dispatching the sample, it was shown to be positive for both the antigen and the antibody. However, 2 weeks later, when we got the results for sample 2006, most labs actually reported it as antibody negative, and only a handful were able to pick up the antibody positive. They all were able to detect the antigen. So this was sort of a question mark to us, and sort of said, what's happened there? So 7 out of the 42 participants reported the positive, and 35 reported the negative, and their variation didn't appear to be related to the lot number or the method at all. Most labs use the same method for HIV point of care testing. So the variation of these results seem to be due to the matrix itself, so the whole blood sample that we prepared, and it might have been due to assay sensitivity at the low levels, because we did expect a low-level antibody. But what we find with most labs when they use ICT methods, even if they see a faint line, although the kit says that as long as you see a line, it's positive, depending on operator variability, some might say, oh, it's only faint, so it's negative, so the report is negative. So the sample, when we then did some more testing, we usually do homogeneity testing before we actually dispatch the sample. So it was found to be homogeneous before dispatch. However, the red cells have limited stability, which is why we only have the survey open for 2 weeks. And loss of reactivity may have occurred depending on the time of testing. So we usually encourage the labs to test as soon as they receive the samples. Most of these HIV point of care samples go to clinics, and sometimes they might leave the sample for a couple of days before they actually do the testing. So when we followed up with the labs and when we also did our internal testing, we found that when they tested the sample earlier on in the survey open period, they actually got the right results. But when you tested it later on, they were getting the negative result. So it seemed to be a loss of reactivity over the time period. So for this survey, even though we did get 80% consensus, with most people calling it negative, we chose not to assess the sample because we did know that there was antibody present for those who did detect it. So just to sort of summarize the potential causes of your discordant EQA results, it could be due to a poor method or assay performance, in which case you should contact your manufacturer. The sample type might actually be unsuitable for the kit that you're using, or they might be matrix effects that are causing discordant results. Inappropriate storage of samples. We do find a lot of labs leave their samples out in the refrigerator instead of freezing them throughout the survey period. So that might actually affect the stability of the sample over time. Transcription errors. So this should always be checked during the pre-analytical and post-analytical phase and before testing the sample. Some labs choose to relabel our samples before they put it on the analyzers, which is where we find a lot of the issues. Varying assay sensitivities at low level of antibodies. Again, this is something that you should follow up with your manufacturer if you're concerned. And then technical difficulties with the assay performance. So I just wanted to acknowledge the serology team. This is our small team at the QAP. Everyone works really hard on the reports and preparing our samples, and we're always happy to talk to anyone who has any questions. And thank you. If you're interested in any of our posters, you can find them at that bottom link on the slide.